Okay, ladies and gentlemen, I'm back, and I cut the last video off because they're getting a little bit too long. So this is now video number 6 of the series on motion and energy. And I'm going to kind of finish things here with a quick review, just to remind you that Newton's first law says an object will stay at rest forever unless an unbalanced force acts on it. An unbalanced force is like a push or a pull. Once it's moving in a straight line, it'll continue forever unless some outside force stops it. The second law says that the acceleration of a mass, whether it's circular acceleration or linear, is directly proportional to the force applied and inversely proportional to the mass. So if I apply a small force, I get a small acceleration and a small final velocity. If I apply a large force, I get a larger acceleration and a larger final velocity. The work that I do goes into the kinetic energy that the object has in this particular case. The third law was that for every force in the universe, there's an equal and opposite force. So if I lift up on this car, the car pushes down on me with an equal and opposite force. That is, if it's not accelerating. So if, well, even if it is accelerated, that is the case. If I push up on the car pushes down on me. If I walk, if I push back on the earth pushes forward on me. Well, I like to do a fun experiment that involves Newton's second law. And that is using a string, and if I wrap this string around my hand and pull, it breaks at about 10 pounds. That's quite a large force for a small string. And what I've done is attached strings to a mass. It happens to be, I'll come out here in front, it happens to be a small vise that I have in my workshop. And I've attached strings to it so that if this mass weighs about 5 pounds, the question is, which string will break first? The top string, or I have strings on the bottom here, or the bottom string. Let me get it. Which string will break first, the top string or the bottom string when I pull down? Remember, the string is going to break when there's a tension of 10 pounds here, and this already weighs 5 pounds, so just hanging here, the tension in the string is 5 pounds. The force that the string exerts up is equal to the force that the weight exerts down. Now the question is, if I pull down on this lower string, which string will break first, the lower string or the upper string? Well, everybody with a lack of knowledge of physics will say, of course, the upper string will break first because it already starts with 5 pounds. And if I pull down, that's just going to increase the tension in the top until the top spring breaks. But if we know a little bit of physics, we know that we can pull down in such a way that the inertia, the fact that this mass wants to stay standing there, the inertia will allow me to break the bottom spring before I do the top spring. So here we go. So in the class, I would have bets which is going to break first, the top or the bottom, and then I'll break whichever one I want to. Here I'm going to break the bottom string. Okay, the bottom string broke because I attempted to accelerate this rapidly. The force was large, the mass stayed stationary, and the tension never got to increase up here before that happened. Now if I pull back gently, down gently, I don't want to drop this on my hand. If I pull down gently, oh, I did it. The upper string broke because I wasn't accelerating the mass. The force downward didn't increase that rapidly, and therefore the total force in the upper string was the greatest, and it broke first. Okay, that's the end of my lessons now on force and mass and acceleration and energy. Hope you all had a good time. I'm going to go now and put these on the computer and let you play with them.